All right, based on what we learned yesterday before I had to leave, go ahead and try on your own doing this ChemCatalyst. Hopefully you brought your notebooks with you, so that shouldn't be a problem. Don't forget to write the dates, copy down the full question, and then try and come up with the either conjugate acid or conjugate base for what's given on the screen. All right, so if it's asking you for a conjugate base, that means it's already an acid. So like for example in number 1, HBr is hydrobromic acid. It's telling you this is an acid. What is its conjugate base is what it wants to know. All right, so the first 2 are acids. You're trying to find their conjugate bases. The second 2 are bases, and they want you to find the conjugate acid. All right, these ones shouldn't be too bad. They're either in your homework, possibly we did them in class. Either way, go ahead, try them on your own, pause this video, and then you can kind of see the solutions to see if you got them right. Okay, so now that you're back, hopefully you tried them on your own first and didn't just skip right to the solution. All right, once you're back, we want to think about, okay, what does it mean to be a Bronsted-Lowry acid versus a Bronsted-Lowry base? So hopefully you have your notes nearby. All right, if you're an acid versus a base. All right, if you're an acid, it means you're going to donate protons. All right, you're a proton donor, which a proton, again, is just that H+ ion. If you're a base, that means you're a proton acceptor. All right, so we're going to accept our H+. All right, accept protons. All right, so that's what you kind of want to think of. All right, so in number 1 and 2, it's asking for the conjugate base. So it doesn't know what the base is, which means we must be told what the acid is. So HBr would be considered a Bronsted-Lowry acid, and so would HNO3. All right, so both of these start out already being acids. All right, which means they should be able to lose an H+, and both of them do have an H+ ion that they can lose. All right, so when you become a base, you lose your H+, meaning all that's going to be left over is just a bromine, and then that bromine has a -1 charge on it. So you can either write 1- or just a minus sign, that's fine. All right, but you want to think it's lost in H+, so kind of like we're subtracting H+. It loses not only the hydrogen, but it also loses a positive charge, making it negative. All right, same thing for this one. It started out neutral, so it's also going to become negative, and it's also going to lose an H+. So all that's left over is the polyatomic ion nitrate, NO3, and again, that has a -1 charge. All right, so we lost an H+, meaning we lost not only the hydrogen, but the charge that went with it. All right, these next 2, so numbers 3 and 4, these 2 right here, all right, we're starting out with a base. So it says we already know that we have a base, NH3, all right, and it wants to know, well, what is the conjugate acid? All right, so Bronsted-Lowry bases, remember they accept H+. That means when I go this way, I'm actually going to gain or add an H+. So I'm going to add a hydrogen. So instead of having 3 hydrogens, now it's going to have 4 hydrogens. And I gain this positive charge. So instead of being neutral, I'm actually going to have a +1 charge. All right, so if you start out as a base, like these ones are, all right, our next one's OH-, you're going to gain not only an extra hydrogen, but also the positive charge that comes with it. So you added an H+ here. Now instead of 1, we have 2 H's. All right, so you can think of it like OH2, but hopefully you kind of realize what this is going to be. All right, if we add a positive charge, we have a positive charge plus a negative charge. That's going to make it neutral. So instead of writing OH2 with no charge, hopefully you realize this is the same thing as H2O. All right, on a quiz or a test, I won't be super picky about that, but start to recognize those patterns when you see them. Okay, so that's the ChemCatalyst. We're going to go ahead and do a little bit more review of what we did yesterday. So go ahead, get out your notes from yesterday so that we can kind of keep going and you can get your homework done for tonight, hopefully in class. All right, yesterday Again, you were introduced to the Bronsted-Lowry definition of acids and bases. All right. We talked about conjugate acid-base pairs within that. All right. Again, the only difference is that one has H plus and one has lost H plus. All right. So if you're an acid, all right, you're going to lose your H plus, meaning that whenever you see like your products of what happens to your acid afterwards, it lost that H plus and it forms what's called a conjugate base. So whatever it forms after it lost the H plus is the conjugate base. That's kind of the setup that your homework had when you had to write an equation. It always said, write the acid, and then after the arrow you should have had H plus whatever was left over, which would have been its conjugate base. All right. If you start the other way, all right, if you start out with a base, all right, then bases add H plus. So kind of to this, we're going to add H plus, and then that is what's going to become your conjugate acid. All right, just like we did in the ChemCatalyst and in your homework. What you should notice is that these two equations are basically just the reverse of one another. Yeah, up here we call this a conjugate base, and this one's just a base, but because these are conjugate acid-base pairs, all right, it doesn't really matter which one started out being the first one. All right, so, technically the original acid is the conjugate acid of this conjugate base, all right, and vice versa. So they're a pair. All right, so let's see a couple examples of that, and then we can kind of look at some reactions to get us ready for your homework for tonight. All right, so one example, kind of the most common one, the one that your homework had as an example, is hydrochloric acid. All right, we already know that this is an acid, so it's no surprise to us that we would label this one as our acid. All right, I'm just going to write an A to kind of simplify it. All right, so this is our acid. All right, we know acids lose H plus, so we're going to end up with H plus and whatever's left over, which in this case again is Cl minus. By now this should be pretty easy. All right, acids form their conjugate bases, so that's what this Cl minus is. All right, if I had written it the opposite way, then Cl minus would have been the base and HCl would have been the conjugate acid, but that's not what I did. All right. Another really common example, one we see with Bronsted-Lowry a lot, all right, would be a really common base, NH3, ammonia. All right, so here, again, I'm just going to write a B instead of the full word base. All right, this is a super common Bronsted-Lowry base. Bases gain H plus or accept H plus to become their conjugate acids. Again, this is one we just saw in your ChemCatalyst, and it was in your homework, and it was in your notes, so that shouldn't be a surprise. All right, so again, I'm going to label it Ca because it came from the base and now it's the conjugate acid. All right, all you're going to see in your homework tonight then is what happens when both of these things happen at once. So if these two reactions, all right, happen at the same time, so like if these happen together in the same beaker, all right, what would that look like? All right. And so if you're kind of thinking of adding these two together, all right, let's kind of think of it almost like it's an equation. You're adding them together. Everything that's on the reactant side is going to get added together. Everything on the product side is going to get added together. So we're going to have from our first one, our first reactant is HCl, okay, plus in this one we had two reactants. We had our NH3 and we had an H plus added to it. Okay, then we have our arrow. Let's look at our product side. In this first one, I had two products. I had the H plus that I lost and a Cl minus. All right, and then in this bottom one, I just had the one product, my conjugate acid, NH4 plus. All right, so kind of like we did when we had net ionic equations, all right, kind of like we did there. You're going to cancel out something that's on both sides. In this case, you should just notice that the H plus is on both sides, all right, which is a good thing because that means we transferred it in both of them. All right, and so your homework's going to give you an equation more like this. All right, your homework's going to give you an equation that has something like HCl plus NH3 yields Cl minus plus NH4 plus. And this is an example of a Bronsted-Lowry acid-base reaction or a conjugate acid-base reaction. Those are kind of the same thing. So Bronsted-Lowry, conjugate acid-base, they're the same thing. All right, they come from that same definition. All right, so let's go to a new example. All right, one that's in your homework so that we can kind of practice what do I want to see on your homework. All right, so this example is already given to you, but we're going to go ahead and do it in our notes as well. All right, we're going to have HCl and H2O forming Cl minus and H3O plus. Okay, so this is that first example in your homework. All right, in this one, it's going to ask you to identify what are the conjugate acid-base pairs and then label them as such. Okay, so in this one, you want to look at, okay, well, what substance out of my reactants, which one of these two lost H plus and which one gained H plus, and that's how you tell which one's the acid or the base. All right, and this one is kind of easy because we all know hydrochloric acid is a super strong acid, so chances are that's probably going to be our Bronsted-Lowry acid. But let's just check to make sure. Acids are supposed to lose H plus. If we look over here, if it had lost H plus, all right, then that means it would have become Cl minus, and sure enough it did. All right, so we know right away, okay, this is our acid. That must mean that water has to be our base, okay? But again, let's check and make sure. Did water gain H plus or accept H plus? Yep, it sure did. It became hydronium. It has 3 hydrogens and a positive charge, okay? So it gained H plus, all right? If we kind of match these up, the acid should be forming its conjugate base, and the base should be forming its conjugate acid. Okay, so that's kind of how you label those. All right, in your homework it wants you to actually pair them up as well. All right, so in this one you'd have 2 pairs. All right, the first pair would be HCl and Cl minus. All right, this is your acid. This would be the base in that pair. All right, the second pair is H2O and H3O plus. And then this is your base, and this is your acid, all right, in this conjugate acid-base pair. All right, so they are paired up with each other. All right, so that's what I'm expecting to see. If you have more questions, of course, email or just ask each other, use your book. There's lots of resources available. All right, good luck.